So here we have a rational function, and we're supposed to find all of the asymptotes. So I'm going to do the horizontal asymptote first. And for the horizontal asymptote, it's basically saying if x is going to infinity, then what is y going to? So if x is going to infinity on the numerator, plus 7 doesn't really count for that much. Also, the plus 8x doesn't really count for that much. So you just look at the numerator, what's the most powerful term? That would be the x squared. Do the same thing for the denominator. That would be 8x squared. So for the horizontal asymptote, I can say that the y value is approximately like x squared divided by 8x squared. And then those x's are going to cancel, and it's going to leave y equals a 1 over 8. All right, then the vertical asymptote. So for the vertical asymptote, all you do is you take the denominator and set it equal to 0. So we're trying to find out where this thing is undefined. So just set the 8x squared plus 8x equal to 0. And then I could factor that. So I could factor out 8x. It's going to leave 8x times x plus 1. And then set these equal to 0. So we'll get 8x equal to 0. And then also x plus 1 equals 0. So two solutions seem to be x equals 0 and x equals negative 1. Okay, that means that when I look at the graph, there's going to be a vertical asymptote at x equals 0. That's a great time to use a red pen, and then put a dotted line, and the function will be undefined there. Also, at x equals negative 1, it seems that there's two vertical asymptotes like this. And then for the horizontal asymptote, that means if you go to a y value of 1/8 and you go off to the right, then the function is going to get closer to it. I don't know if it's going to come from the bottom up or the top down. We'll use a graphing calculator in just a second. And then also going this direction, again, it's going to get close to that, but not touch the horizontal line. And then let's graph it and see what it actually looks like. So go over to the graphing calculator, and I was practicing right before you got here. So I went ahead and typed it in. Let me double check that I typed it correctly. Got my parentheses. Everything looks good. And then for the window, I'm just going to go from negative 10 to 10 on the x's and negative 10 to 10 on the y's. And then the graph looks like this. So I can see that there is a vertical asymptote at x equals 0. So this part is going to go up to infinity. This part is going to go down to negative infinity. Also, if you fall it off to the right, in the upper left-hand corner, the y value, let me move over a little bit more. The y value is becoming a 0.186, 185. Well, 1/8 is, what is 1/8 as a decimal? Of course, I could do that in my head real quick. As I'm typing in the calculator, it's 0.125. So if I follow this graph out far enough, then the y value is eventually becoming 0.125. Okay, so all of that's good news, but there is something strange, and that is I got that at x equals, let me just type it in. I got that at x equals negative 1, the graph is supposed to be undefined. And it is undefined. Up there in the left-hand corner, it says non for does not exist, and yet there's not an asymptote. That means I need to go back and check my work. So go back, and what happened? So it seems that this x equals 0 was correct, but this one is not a vertical asymptote. So I need to erase this dotted line. And then why did that happen? Okay, so let me show you with math rather than with a picture. So if you go back to the original function, and then factor it. So on the bottom, I already factored it. So that's 8x times x plus 1. On the top, this could be factored as, well, I need two x's in order to get x squared. In order to get a 7, use a 1 and a 7. And then after you have it factored, notice that x plus 1 shows up on the top and the bottom, so they cancel, which then cancels this answer. So my final answer is the horizontal asymptote was correct, and the x equals 0 for the vertical asymptote was correct, but x equals -1 gets thrown out.